record, and yes. Okay, perfect. So then, all right. So let me just find first the homework. So where is the homework? Let's see. So so we are at homework number 7, and okay. All right. Um, so this is about the homework number 7. Right, the last two problems. All right, so the homework number 7, the goal of the homework number 7 is to apply the chain rule, right? Chain rule. Now, for the last two problems, so the first one, so we have like cosine sine to the power 8 of x, right? So let's say you have a function h of x. So I'm going to do a similar problem, not exactly the same, but I'm going to do a similar one. All right, so let's say you have sine of cosine square of x. Okay, so this is sine of the square of cosine. Okay, so again, so so we want to compute the derivative, right? So you have to ask yourself which rule you're going to apply. So this is sine of cosine square of x. So it's not a multiplication. This is not sine times. I mean, here it's not multiplication, right? This is here. It's a composition. Okay, so this is composition of function. So it's not a product. So it's a composition of functions. So this is a composition of functions, not a product, right? It's a sine of something. It's not sine times cosine square. So it's sine of cosine square. So so it's composition of functions. And as I said, this would be sine of the square of cosine. So this is like saying f of g of L. Okay, so then your f would be the sine, the square, that would be your g, okay, and the cosine, that would be your function L. Okay, so what I'm saying is that f of x, so let's say f of x is sine of x, okay, and so L of x is we said L of x is cosine of x, and g of x, right, is the square of x. So g is it's a function, right? It's a g of x, g of some variables, g of x. So it's the square of x, so x squared. Okay. Now the thing is, if you do f of g of L of x, that will be exactly function h. So what I'm saying is that if you do, if you do, let's say g of L of x, so what's g of L of x? So you have to, substitute this x by L of x. Okay, so this x here, you have to substitute this x by L of x. So that would be L of x is cosine, right? So that would be cosine square of x, right? That's my g of L of x. And now you want to compute, let's say, f of g of L of x, right? So f of x, we said f of x is sine of x, is sine of x. Now f of g of L of x, So we have to substitute the x, the x in f of x by the g of, L of x, right? So then that will be equal to sine of, and then you substitute this x with g of L of x, but g of L of x, that's exactly this, the cosine square, right? So my g of L of x is cosine square of x. So you see, when I compose this f with the g with the L, I get exactly my function h. That's exactly my h of x. So this is exactly my h of x. So what I'm saying, guys, is that this function h of x is the composition of three functions: f, g, and l. It's not a product. It's not a multiplication. It's a composition, and it's actually a composition of three functions. Why it's a composition of three functions? Because when you take a look to the function h, you're gonna see that there's a sine. That's the first function. You're gonna see the cosine. That's another function, and you see that there's the square, and that's the third function, right? So here we have three functions, three different functions. We have the sine, we have the cosine, and we have the square, and that's like three functions, right? And what I'm saying is that my h of x is the composition of these three functions. So first function f, that will be the sine. The power, that will be my g, and the cosine, that will be my L. All right. Now, so once you find your three functions, so that's like this is like the first step. You have to find the three functions f, g, and L. So you have to express your h as a composition of three functions f, g, and L. That would be first step. The second step, of course, would be to compute the derivative. So now you have to compute h prime. So this is like step number 2. So let's say this is step 1. So in step 1, we have to find like the three functions. Step 1, okay. I got my f, g, and L, and such that f composed with g composed with L would be my h. Now in the second step, I have to compute h prime, right? But I mean, we just said in the first step, we said that h is actually a composition of f with g and with L of x, right? So that's the composition of three functions. So our chain rule, so this is the chain rule for three functions. So when you have the composition of three functions, then the chain rule is the following. So then h prime would be L prime of x, g prime L of x, and then f prime g of L of x. Okay. So that's our chain rule when you have a function composed by three functions, okay? F, G, and L. Right, so then you have to compute the L prime, the G prime of L, and F prime of G of L. So first, let's start with L prime. You know that L of x, we said L of x is the cosine, right? L of x is cosine. So L of x is cosine of x. So then L prime of x, derivative of cosine is cosine of x. It's minus sine of x, right? So we got our first term here in the formula, L prime of x, right? That's L prime of x. Next, we need g prime of L of x. Okay, not just g prime of x, but g prime of L of x. Now, first question is, what's g prime of x? So, well, with g of x, we said it's just x squared, right? So then g prime of x, derivative of x squared, you bring down the power 2 in front of x, and you subtract 1 from the power, so that'll be 2x. But what I need is g prime of L of x. So I need g prime of L of x. Right? So we need to substitute the x, this x. So we got one x here, in 2x, there's one x. Right? So we have to substitute the x with L of x. Right? So that will be equal to 2. And so x is going to be now L of x. And L of x is cosine, right? So there's going to be 2 cosine of x. Right? So I just substitute the x with the L of x, right? So now I got my g prime of L of x. Next, we need f prime of g of L of x, right? So we're gonna need f prime, but not just f prime of x. We're gonna need f prime of g of L of x, right? So what's f prime? Well, f of x, we said it's, so f of x is the sine of x. That's the first function. That's the sine of x. And so f prime of x, it's just a derivative of sine of x. It's just cosine of x. Okay, cosine of x. Now, we need, we said we need not just the f prime of x, we need f prime of g of L of x. So we need to substitute x by g of L of x. But what's g of L of x? Well, so you see here, guys, this is g of x. G of x is equal to x squared, right? But then g of L of x. Okay, so you substitute x. So x, this x here, we substitute the x with L of x. So L of x is cosine of x, right? So so it's gonna be cosine, and there's a square, so it's cosine square of x. Right? So what I'm saying is that g of L of x is cosine square of x, right? So now come back to f prime of x. So again, I need f prime. I need to compute f prime of g of L of x. All right. So I need to substitute this, this x here, this one here, by g of L of x. Okay. So it's gonna be cosine of, so instead of x, we're gonna have g of L of x. Now, what's g of L of x? Well, g of L of x, we said it's cosine square, right? So g of L of x, it's cosine square of x. So here we're gonna have cosine square of x. Again, it's composition of functions, guys. It's not a product, right? So I have to substitute x by g of L of x. Right, so I got, let's come back to the formula. So we need L prime. We computed L prime of x. We needed the g prime of L of x. We got our g prime of L of x, and then we need f prime of g of L of x, and that's exactly this cosine of cosine square of x. Okay, so now I can answer. So now we can answer the question. So then h prime. So then h prime of x, it's L prime of x. That's minus sine of x. Then then we have g prime of L of x. So where is g prime of L of x? Here. G prime of L of x, we said it's cosine of x, 2 times cosine of x. So it's times 2 cosine of x times, and sorry, and then we have f prime of g of L of x, and here's f prime of g of L of x. So it's cosine of cosine square of x. Okay, so it's minus sine of x times 2 times 2 times 2 cosine times cosine of cosine square of x. It's not cosine times cosine square of x, it's cosine of cosine square of x, right? So, and another way to write the answer would be to move the 2 to the front. So then h prime of x would be minus 2. So I just move this 2 here to the front. Okay, so it's minus 2 times sine of x times the cosine of x times the cosine of cosine square of x. And so that would be the final answer. So yeah, so this problem it's about applying the chain rule for the composition of 3 functions. So remember, guys. So I think the hardest part here is to find the f, g, and l, right? Remember, when you have a composition of functions, it's going to be of the form f of g or f of g of l, right? So here we have sine of, it's not sine times, it's a sine of the square of cosine, right? So that's why the first function will be f, the square, it's my g, and the l is the cosine. And then, of course, you have to apply the chain rule for composition of 3 functions. Any question, guys? Do you think it's a lot? Well, I mean, that's the rule. I mean, there's no other way to, I guess, to present this. But yeah. All right. So that's for, I guess. So this is similar, very similar to the first one. The second one. So this is. So is there any question, guys? Any comment?
No questions.
Okay, perfect. So then, okay, let me do like a similar problem to the next one. So this is a problem. Let's call this problem 1. So let's call this one number 1. So this is problem number 1. Okay. Now next one. The next one is the same idea. So all you have to do, guys, is you have to identify the f, the g, and l. So in the problem number 2, so I'm going to do something which is similar to the last problem in the homework. So number 2, let's say you have h of x equal to, so instead of sine, let's say you have cosine of, well, let's say x squared minus 1 to the power 99. Okay. So the question, guys, how many functions do you see there? I mean, how many to how many functions we can compose this h? So, I mean, you see, you can see there's cosine, right? That would be like my first function. There is this power 99, and there is this x squared minus 1, right? So it looks like we have like 3 different functions. So the cosine f of, so cosine of what? Cosine of, cosine of x squared minus 1 to the power 99, right? Or in other words, that's the cosine of power 99 of x squared minus 1, right? So it's f, so this is like saying, so this is like saying cosine of power 99 of x squared minus 1. Okay, so this is, so the cosine, that will be my f of power 99 of g of l. So the l would be the x squared minus 1. Okay. So, and then, so then my f of x, so then my f of x would be cosine of x my g of x, that's the power 99. So of course it's g of x, so you need a variable, not just power 99, you need a variable. So the variable is x, so it's x to the power 99. And then L of x, that will be the x squared minus 1. Okay, and so the claim is that h of x would be equal to f of g of L of x. All right. So then, of course, then to compute the derivative, you have to apply the chain rule. So then your h prime of x would be L prime of x, g prime of L of x, f prime of g of L of x. Right? As I see there's a question in the chat. Okay. No problem. All right. So yeah, and then and then of course you have to do the same computations as I did in the previous example, right? You have to compute f prime, g prime, f prime, etc., etc. And so you have to find, you have to find this. This L prime of x, and then you have to find g prime of L of x, and then this f prime of g of L of x, right? Given that your f is this function, your g is this one, and your L is this one here. All right, so this is same. It's just the same way as the previous problem. Okay. Is there any question, guys? Okay, so
Wait, Professor,
then,
Professor,
yes.
sorry.
Mm-hmm.
I just want to know, how do you directly differentiate a trig function? How do you make sure that it's the derivative function that you get is the direct derivative of the trig function originally?
You mean like derivative of cosine of x, or
Yes,
sine?
yes.
Now, I mean, so in section, I think section 2.5, if I'm not mistaken, in section 2.5, we computed, like using the limit definition, we computed the derivative of sine of x, the derivative of cosine of x, etc., etc. So, all the formulas we have for the derivative of trig functions, we computed them in section 2.5. Right. So what I'm saying is, so when I say cosine of x, so for example here, f of x is cosine of x, right? So you are asking why f prime of x is sine of x, right? Is that the sense of your question?
Yes, Professor.
Mm-hmm. So yes, sorry, minus sine. So yes, so we computed this in section I think 2.5. So we proved this. We proved that the derivative of cosine is minus sine using. So this was proven in section 2.5 using the limit definition of the derivative. The limit definition of the derivative. Remember, we said, so the definition of derivative, limit definition of the derivative. Remember we said, so the derivative, definition of derivative f prime of x was, f prime of x was limit, this h going to 0, blah, 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 f of x plus h, minus f of x over h. This is the definition, the first definition of the derivative, right? So we use this in section 2.5, right, to compute the derivative of cosine. And we proved that the derivative of cosine is actually minus sine. And we did the same for sine of x. So using this limit definition, we proved that the derivative of sine is cosine, etc., etc. Okay. So I mean, just check the notes or the recording of the section 2.5. You can find the proof there. All right. Does this answer your question or not at all?
Oh, it answers it. Thank you.
Okay, perfect. Yeah, so I mean, we didn't come up with this, all these formula, like derivative of trig functions. I mean, with exponential, we did the same. We did the same with the exponential, with the log. So we tried to prove all the derivatives formula we have, right? Yeah, so that's actually a good point because I can, yeah, I can probably remind you. So what we did for the exponential and the log, right? So I think last time on Monday, we had an exercise about logarithmic functions, the derivative of log, right? So I can probably move to the next page. All right. So yeah, so just to remind you, so we are in section 2.7, right? And again, it's about derivatives of log, logarithmic function, and exponential functions, right? So in this section, guys, we computed using the limit definition of the derivative. We compute derivative of exponential. So let me just remind you of the rules. So for exponential, we said, so f of x is e to the x, then f prime of x. So this is the definition of the actually exponential of x. Derivative of exponential of x is just the same. It's exponential of x, right? But then we said if you have exponential, and this is a consequence of the chain rule, if you have exponential of some function g, so the power here, exponent is g, then the derivative f prime of x should be g prime of x e to the g of x, right? Now, so that's for the exponential. And then we computed the derivative of log, right? So on Monday, we computed, we proved, or we computed derivative of log. So we said that if f of x is natural log of x, so ln, this is natural log. So this is a log in base e, right? This is natural log. Okay, and what do I mean by natural log? That's the log in base e, the number e. Okay, so we said if f is natural log of x, then f prime of x would be 1 over x. Okay, so derivative of a log, natural log, is 1 over x. Okay, and we proved, so as a consequence of the chain rule, so if you have f of x equal to log, natural log, let's say, natural log of some function g, okay, so natural log of g of x, so consequence of the chain rule, f prime of x is actually equal to g prime of x over g of x. Right? And so we had an exercise about the derivatives of log, right? So let me just remind you, I think I solved number 1. So I need probably to solve number 2, 3, and 4. So let me just remind you number 2, 3, and 4. So this was an exercise we had on Monday. Exercise. So I solved number 1, and number 1 was about product rule. But number 2, so we have h of x equal to x minus x squared over natural log of x minus 1. Right? And of course, the question is to compute, you want to compute h prime of x. Right? So how do we compute h prime? Well, first question is, which rule I'm going to apply? Do you have to apply the product rule, the quotient rule, or the chain rule? Product rule, is it a product? Is h of x equal to product of functions? Well, it's not really a product, right? It's not multiplication here. It's a quotient, right? Here we have a quotient. So we have to apply the quotient rule. So this is a quotient. So because it's a quotient, so we have to apply the quotient rule. Right? Okay, so remind you again the quotient rule. So you have F over G. So if you have F over G, okay, so the top, that will be my F of X, and the denominator, the bottom, that will be my G of X, right? So if you have F of X over G of X, the derivative, so then this is the quotient rule. So that will be F prime of X times G of X minus F of X times G prime of X over G squared of X. Okay, so that's the quotient rule. Now I have to compute, so I want to apply this formula, right? So I need F prime, I know G, that's the bottom, minus F, that's the top, times G prime, so I need G prime of X, all right? And the denominator is just the square of the bottom. So I need F prime and G prime. So let's compute F prime and G
Hold
prime.
on, Professor,
So,
can you slow
yes.
down a little bit?
Yeah, sure. Here?
Thank you. Yeah, with the F, yeah, with the last that you.
The last rule? Here? Is that okay? Okay. Okay. Well, so then, so I was saying F of X is the X minus X squared, right? And we said that the bottom, G of X is natural log of X minus 1. Okay. Now, when I look to the function F here, this is my this F of X, and I want to compute F prime. So again, I'm going to ask myself, is it a product? It's not a product. It's just a subtraction, right? F of X it's just a subtraction. And we said, if you have a subtraction, so you don't have to apply any rule, just take the derivative of the first here one, the first function minus the derivative of the second function. So derivative of the first function is, so it's X, which is like X power 1. So X power 1 derivative, you have to bring down the 1 and subtract 1 from the power, right? So that will be 1 times X to the 0, and that will be 1. So derivative of X, it's just 1. Minus, now for the X squared, that's a power rule. Again, bring down, put the power in front of X, times X to the power 1, right? You decrease the power, you subtract 1 from the power. So it's 1 minus X to the power 1, right? This is power 1. Now, what about G prime of X? Well, G prime of X is not a product. It's not, it's not a quotient. It's just a subtraction. And again, if you have additional subtraction, then that's actually a good news because you don't have really to apply any rule. All you have to do is just compute the derivative of the corresponding function. So it's like, first I have natural log of X. So what's the derivative of natural log of X? Well, I can check my formula. So F of X is natural log, then the derivative F prime of X is 1 over X. Okay, so the derivative of natural log of X is 1 over X. So here, G prime, so we're gonna have derivative of derivative of this natural log of X is 1 over X. And then there's minus, so here's my minus. Now we have 1. So the question is, what's the derivative of 1? So 1 is just a constant by itself. So when we have a constant by itself, derivative is just 0. So it's minus 0. Okay? Because it's just a constant by itself. And yeah, so I got my F prime, I got my G prime. So I'm good to go. So I can compute now my h prime of x, right? So then my h prime of x, we said, so derivative, it's a quotient rule, so it's f prime. So where's my f prime? Here's my f prime. It's 1 minus x. So minus x, 1 minus x times g of x. What's g of x? Well, it's the denominator. It's the natural log of x minus 1. All right, and then there's a minus. There's this minus here. So here's my minus. F, it's the, f is the top. So minus the x minus x squared times, all right, and then I have g prime of x. So what's g prime of x? Well, here's my g prime of x. It's just the 1 over x. 1 over x minus 0, of course, it's just 1 over x. So it's 1 over x over the whole thing over the square of the bottom. So the bottom is, denominator is ln of x minus 1, and then I have to put the square. Any question, guys, about how I got this h prime? So it's just the quotient rule, now, of course, you can try. I mean, this is I would say this. So this is a correct answer, but you can also try to simplify your answer, right? You can see if we can see if we can simplify this. So let's see. So what I'm gonna do, I'm gonna distribute and see if there is any cancellation, right? So my h prime of x is gonna be, well, it's 1 times, so I'm gonna distribute. So 1 times log, natural log, and then 1 times 1, right? So it's natural log of x minus 1 times 1, so it's minus 1. And then there's this x here times natural log, so it's minus x natural log. And then there's minus x times minus x times this 1 here. That will be plus x, right? Minus minus, that will be plus, so it's plus x, right? And then here, x times 1 over x. So x times 1 over x, so x over x cancel out, so it's gonna be 1, right? So it's gonna be here, this is a plus x, so it's minus 1. Oh, I forgot to put the 2. Yeah, thank you, Elias. Absolutely. Thank you. I forgot the 2 here. So this is here, it's 2x, of course. Yes, thank you. I forgot the 2 because you see here, derivative of x squared, of course, you bring down the 2. So there's a 2 there. Yeah, thank you, Elias. Thank you, I appreciate it. So this is minus 2x. I forgot the 2, of course. And then, so then that will be, let's see, so it's minus 2x here. I forgot the 2 here. So it's 1 times natural log, that's natural log. 1 times 1 minus 1, that's correct. And then minus 2x, natural log of x, and then plus 2x. Right, and then there's this minus, and then x times 1 over x, that's 1, right? X times 1 over x cancel out, so it's 1. And then minus minus, that would be plus, and then we have x squared. You see this x squared times 1 over x, so x squared over x, power rule. So it's going to be x to the power 2 minus 1, so it's just x. So it's plus x. This is plus x, and of course the whole thing here over this natural log of x minus 1 square. All right, so now let's see if we can, if there's any cancellation. Well, we can simplify. Yes. Okay, I thought someone's gonna say something. Okay, so h prime of x. Well, So let's see, we have natural log of x. This is natural log of x. So here's my natural log of x. There is, Robert, okay, thank you. Thank you for letting me know, thank you. So there's -1. So there's this -1 here, and there's a -1 here. So that'll be -2. So -2. Then there is this -2x ln of x. So it's -2x ln of x. And then there is this, plus 2x plus x. So that'll be plus 3x. So this is plus 3x. And the whole thing, of course, divided by this natural log of x -1 squared. Okay, so I guess this would be like the final answer here after simplification. Any question, guys?
No more
All right.
questions.
Okay, perfect. Then, so that's for number 2. Number 3. So the homework tomorrow, homework number 8 tomorrow is going to be about exponential, derivative of exponential and derivative of log. Okay, so yeah, so we have the opportunity to practice a derivative of exponential and log in the homework number 8. All right, so next one, it's number 3. So problem number 3. So we have h of x equal to natural log of cosine of x. Okay. So here, guys, so we have to be careful. So this is not natural log times cosine of x. It's really natural log of cosine of x, right? This is so this is natural log of cosine of x. Okay. So for example, I want to compute, let's say, h of 0. So what's h of 0? So there'll be natural log of cosine of 0. So the angle is 0, right? So first, I have to find the cosine of 0, cosine of the angle 0. Cosine of the angle 0 is 1. So this is actually natural log of 1, right? This cosine of 0 is equal to 1. And now I have to, it's not natural log times 1, it's natural log of 1, right? It's not natural log times 1, it's natural log of 1. And what's natural log of 1? Well, it's 0. Okay. Actually, log of 1 in any base is equal to 0. Okay. So I'm just trying to explain that this natural log of, it's not natural log times cosine, it's natural log of cosine. So it's like here, I'm saying natural log of 1, not natural log times 1, right? Anyway, so yes, so that's natural log of cosine. And when you see the word of, it means composition. It's f of g, right? So it's not a product. Okay, let me just erase this. So if you have the word of, so that means we have a composition, and we say, when we say composition, we say, of course, the chain rule. Okay, so that'll be the chain rule. And actually, we said for natural log, as a consequence of the chain rule, so if we come back to our rules here, you see here, if you have a function f, which is natural log of some function g. So we have a natural log of some function g. Then we said, as a consequence of the chain rule, the derivative would be g prime of x over g of x. Okay. So so what I am saying here, guys, is that so we have already a formula for this natural log of cosine of x. So so what I'm saying is here, so if your h of x, let's say your h of x is natural log of g of x, right? Then h prime, as a consequence of the chain rule, so we proved this formula last time, the h prime of x would be g prime of x over g of x. Okay, and you can see, so my log here, my h here, so it's natural log. So my g of x is gonna be this cosine of x, right? This cosine of x, that will be my g of x, right? It's natural log of g of x. So g of x, so g of x is cosine of x. Okay, and so then g prime, h prime, so we need to compute h prime. We said h prime is g prime over g, so g of x is cosine of x, g prime of x, we said derivative of trig functions, derivative of cosine of x is minus sine of x. Okay. So then the answer, h prime, so the answer, h prime of x, so which is g prime over g, so that would be minus sine of x over cosine of x. Okay, and sine of x over cosine of x, of course, that would be tangent of x, so that's minus.
Professor, can you go
Yes.
up a little bit?
Go up, yeah, sure. Here,
A little bit more.
more, okay.
Yeah, right there.
Mm-hmm. And yeah, so minus sine over cosine, guys, that will be minus tangent of x, okay? So the answer would be minus tangent of x. So next, and the last problem is when you have sine of natural log of x, right? So that's kind of different from the number from the previous one, number 3, right? Are you done, Taisha?
Yeah, you can move on.
Oh,
I
oh,
took a
okay.
picture of
Oh,
that.
okay. Oh, okay. Sure. Thank you. All right. Thank you. So then, okay. So then, the sine over cosine, that would be tangent of x. That's the definition of tangent of x. So the answer, that's minus tangent of x. Anyway, so the next one, number 4, we said, so number 4, h of x is sine of natural log of x. Okay. So this is sine of natural log of x, right? So this is not, of course, this is not of the form natural log of g of x, right? This is not, so this is not natural log of g of x because the natural log is inside the sine. It's not outside. The natural log here, it's not outside the, outside the parentheses, right? So this is not of the form natural log of g of x. This is sine of natural log, okay? So we cannot really apply, we cannot apply this formula, this one here, because, it's not natural log of something. It's a sine of natural log. So, but anyway, it's still, we have this word of, sine of natural log. So then it means that's a composition, right? It's a composition. It's not a product. It's not sine times the natural log. So it's composition of 2 functions. And so if we have a composition of functions, then you have to apply the chain rule. So we said it's a sine of natural log, so f of g, so then sine would be f and the natural log would be g. All right, so my f of x, so my f of x is sine of x, and the g of x, that would be natural log of x. And so when you do f of g, so when you substitute x with g, so we substitute this x here with the g of x, substitute this x with the g of x, so we're going to have sine of, so g, what's g? Well, g is this natural log of x. So f of g of x is exactly my, this is exactly my h of x, right? This is exactly this function here. So my function h is a composition of these two functions, f and g. And so now we can apply the chain rule. I got my f, I know my f, I know my g. So now I can apply my chain rule. So then the chain rule says that h prime of x is equal to, so this is the chain rule. Okay, so then that's g prime of x, f prime of g of x. All right. Now, what's g prime? Well, g is g of x is ln of x, right? G of x is ln of x, natural log of x. So then g prime of x. So we know, we proved that, I mean, derivative of natural log of x is, you know, it's 1 over x, right? So so we proved that the derivative of natural log of x is 1 over x. Now, next, we have f prime of g of x, right? So first, we need f prime of x. Well, f of x, it's sine of x, right? So then, right, so f of x is sine of x. So then f prime, of x would be cosine of x. Now the question is, what's f prime of g? Okay, so f prime of g, so we substitute x with g, so that would be cosine of, substitute this x here, this x, right, this x here by g, so that would be cosine of, g is natural log of x, so it's cosine of natural log of x. Okay, so then the answer, h prime of x, we said h prime of x supposed to be g prime of x times f prime of g of x, right? So then g prime of x, we said it's 1 over x times f prime of g of x, that's the cosine natural log of x. Okay, and that's a fine answer. I mean, there's no simplification, so it's just, that's the fine answer. Any question, guys? So that's for the exponential and the log. I think we did a lot of examples, but still, I guess, I mean, if you are doing this for the first time, guys, the derivative of exponential and log, again, my advice is to practice all these rules, right? The chain rule, the product rule, the quotient rule, right? So it's really important, you know, to practice this notion of all these rules, right, to compute the derivative. Anyway, all right, so we are not done yet actually in this section, because we're going to have more examples. And now we're going to have some kind of special examples, okay? So, well, first, is there any question, guys? Any specific question about the log or exponential? All right, so we know.
I have a question.
Yes, please.
So once you put there, that's an L up there, LN or EN?
That's LN.
Okay,
That's
so
natural. That's natural log. LN. Okay. LN stands for natural log. The L is for the log, and the N is for natural.
Okay, so what you're doing is you're applying you solve the equation. No, you divide, you break up the equation, and then you plug it in to the chain rule.
Yes,
and then that's
absolutely.
when, and then do you keep solving it if you can, or you just leave it the way it is? That's how we're doing.
Yeah, yeah, you
Okay.
keep solving. I mean, if you can simplify, or if there is any possible simplification, then yeah, you keep trying to solve the equation. But
Hello?
otherwise, yes, I was saying, sorry, there's
No, I'm sorry. Yeah,
I'm
yeah,
not.
continue.
Probably I should mute. Yes. So sorry. Yes. So I was saying, if there is any simplification, then yes, you should try keep solving the equation if there is any possible simplification. But I mean, in general, there will be no simplification, and there will be like a final answer. But sometimes you need to try to distribute and see if there's any simplification.
Okay, thank you, Professor.
Okay. Mm-hmm. All right. So then, yeah. So we said we're gonna have more examples, kind of very special examples, and so more examples. Right. So let's say I have the function h of x. Right. So h of x equal to x to the power x. Okay. So what will be h prime of x? Okay. So so guys, any guess which rule I'm gonna apply here? Is this exponential? Is this a power rule, or exponential, or in base x, or
Power rule?
well, the problem here, yes, actually, you see, the thing is, x is at the same time is the exponent and the base, right? So actually, we cannot apply the power rule, because x is also the exponent. Okay, so so what I'm saying here, so x is at the same time exponent.
But I thought an exponential rule has to have the e. Is that how it goes? Of which
No,
one?
exponential. No, well, exponential. We had on Monday. We had a formula when you have like a to the x. Like if you have some number a to the x, we said h prime. So on Monday we proved that the derivative of a to the x is a to the x times natural log of a. But then we said if a is yes. So if a is the number e, the exponential, then h prime of x is going to be just e to the x. But natural log of e is equal to 1. So then h prime of x is just e to the x. Right? So what I'm saying is the exponential of x, it's when we have the exponential function, it's when the base is some number a. E to the x is just a special case of the exponential functions.
Okay, so when you have a to the x or a in it, that means
yes. When you have a to the x, that's what I call exponential function. Actually, that's the exponential function with base a. Now, there's a special case when the a is equal to the e. Okay, so that's the e to the x, and that's the and so the log in base e, that's the natural log.
Okay, got you.
So yeah, yeah. So but anyway, so this is in this x to the power x. So x is at the same time exponent. Sorry, I have to unmute. Okay, mute. So x is at the same time exponent and base. Okay. So remember so the exponential function is when we have a number to the power x, and the power rule is when you have x to the power n. Well, this is exponential base a, exponential base a, in base a, and this is x to the power n, right? Power n of x. This is power n, x power n. Okay, but the n here, x power n is supposed to be a number, right? This n here, x power n is supposed to be a number, okay? A constant. This is supposed to be a number, right? But here, it's not a number. Here, it's a variable. I mean, x to the power x. So my x here, it's not a number, it's a variable. So this is a variable x, okay? So what I'm saying, guys, is that this x to the power x, it's not of the form a to the power x. It's not an exponential in base a, and it's not x to some power n. Okay, because the power here, it's a variable. It's not a fixed number, right? Okay, so we need to figure out how to compute this, the derivative of this function h, right? Without using the exponential or the power rule, okay? So, well, so the idea, guys, is that whenever you have an x as exponent, as a power, we apply what we call the log trick. So the idea, so how to compute the derivative of such function. So the idea is, so whenever you have x, x as a power, we apply x as a power, we apply the log trick. Okay, so what's this log trick? Well, so let me explain this log trick. There are two steps in the log trick. So step one, so we have to apply log. So step one is to apply natural log ln to both sides. Okay, so for example here, we have h of x equal x to the power x, right? So we have h of x equal to x to the power x, right? So what we're gonna do, we're gonna apply natural log to both sides. So I'm gonna apply natural log here and natural log here. Okay. So now, why do we apply natural log? Because when you apply natural log, there's one special property to log. You remember, guys, if you have if you have log of a to the power b, right? That's equal to b times log of a, right? You can, so if you have a log of a to the power b, you can move this b to the front here. Okay, you can bring down this b here into the front, right? So here's your b times the log of a. Okay, so you see why this, I mean, this log, applying this log is important, is because you're gonna bring down the power. So what I'm saying is that I can because of this property, I can move this power x. So you see this power x, I can move it to the front here. Okay, so we're gonna have natural log of h of x equal to x times natural log of x. So again, that's one of the properties of log, right? We have log a to the power b. That's b times the log of a. All right. Okay, so I applied the ln to both sides. That's the first step. Now, next step is to compute the derivative. Okay, step 2. So now you have to compute the derivative. Okay, so I have natural log of h of x equal to x times natural log of x, right? So I want to compute the derivative. Okay, now next step. So the derivative. Now, what's the derivative of natural log of h of x? Any guess? Derivative of natural log of h of x? Well, Adrian, you're almost correct. Remember, yes, Elias, it's h prime of x over h of x. Yes, very good. So remember, guys, we said we have this rule. Well, it's not here, and it's in the last page. Remember when we said natural log of g of x? So let me just remind you here. So if you have natural log of g of x, then the derivative, we said the derivative would be g prime of x over g of x. Okay, so this natural log of h of x, it's like natural log of g of x, right? And so the derivative is g prime over g. So derivative of this natural log of h of x, that will be h prime of x over h of x. Okay. Now, what about the other side? X times natural log of x. So which rule I'm going to apply here to compute the derivative? X times natural log of x. Any guess, guys?
Product rule.
Product rule, very good. So this is x times, right? So it's a product, and so we have to apply the product rule. So, okay, so let's apply the product rule. Remember the product rule. So let's say this is f here, this is g. So then the product rule would be f prime of g times g plus f g prime. Okay, so derivative of x, it's 1 times g times the natural log of x plus f is x, times g prime, derivative of natural log of x. And we know that derivative of natural log of x is 1 over x. So it's 1 over x. All right, so then remember, guys, the goal is to compute the derivative of h of x, right? Remember, we said that h of x is x to the power x, and we want to compute h prime of x, right? That's our goal. It's h prime of x. Okay, so let's come back here to this step number 2. Okay, so we are almost there. So this is h prime of x times, over h of x equal to, so 1 times natural log of x is natural log of x plus So this x, this x over x cancel out. So it's +1, right? +1. And then I want to solve, remember, so I want to solve for h prime. That's my goal. I want to compute h prime, right? So we want to solve for h prime of x. Okay, so I want to solve for h prime. So I'm going to multiply. I'm going to multiply here by h of x, here by h of x, and here by h of x. All right. So then, because when you multiply here the left side by h of x, the h of x is going to cancel out. So that's h prime of x equal to h of x times the natural log of x plus 1, right? And now, what's h of x? Well, I mean, h of x, that's our function. That's our original initial function, right? H of x is the x to the power x. So then this h prime of x is x to the power x times natural log of x plus 1. Okay, and that's a fine answer. Okay, so again, the h of x, that's our original function, the x to the power x. Okay, so then yes, so the derivative of x to the power x is actually x to the power x times natural log of x plus 1. So you see, guys, again, the idea is whenever you have x as a power, you can apply this log trick to compute the derivative. Step 1, you apply natural log to both sides, and then you compute the derivative. Okay. Any question about this log trick? So I'm going to give you an exercise, guys, similar to this example. But first, is there any question? So you see how it works? How I solve for h prime? This is a really nice example, right? I mean, again, it's x to the power x, so we cannot apply the power rule. We cannot apply the just the derivative of exponential. So we have to apply this log trick to find the derivative. All right, so if there's no questions, then here's an exercise, similar exercise. So exercise. So you have to find h prime of x. So 1. So let's say h of x is equal to tangent of x, the whole tangent of x to the power 1 over x. Okay. And then number 2, h of x is equal to cosine of x. So the whole cosine of x to the power x. Okay. So so you see, guys, the goal of this exercise, because in the exponent there's x, I mean in the base there's x, in the exponent there's x, so we have to apply this ln trick or log trick. Okay. So I'm gonna give you 10 minutes, guys, to think about this exercise. So I'm here, guys, if you have any question about the exercise. So again, the idea is to apply this log trick. First step, apply natural log to both sides, and then compute the derivative of the two sides.
Professor,
Yes.
I have a tangent of x to the power 1 over x times, I'm sorry, minus tangent x to the power 1 over x times ln, you open the parenthesis, tangent of x plus secant square of x times cotangent of x times 1 over x. You want me to write it down?
Yeah, if you can write it down. I'm not sure. I don't think it's gonna be the correct answer, but if you can write it down, that would be helpful. I mean, yeah, I mean, it's gonna be a long, well, not long, but I would say complicated expression, I guess. All right, guys. Okay, I don't know if you need more time. I guess we can also take a break of 5 minutes. Let's see, what time is it now? So 30. Okay, yeah. So you know what? We can take a break of 5 minutes, guys, and I will be back at 7:45. Okay, I'll be back 7:45, and then I'm gonna go over this exercise. So after this exercise, actually, we are done with this section 2.7, right? And now, so we know how to compute the derivative of any function, right? So we have now we know all the rules, all the derivatives. So we are done with computing the derivatives. But so next section, I think it's gonna be section. Yeah, as I said, I'm gonna get back to section 2.6. So yeah, next section I'm gonna do the 2.6, and then yeah, so then we'll be done with derivatives. All right, guys. So let's take a break of 5 minutes, and then I'll be back to solve this exercise. All right. Um, so the break of 5 minutes. All right, guys. So let's continue with this exercise. For number one, so let me just move to the next page. This is our exercise here. Okay, so for number one, we have h of x. So h of x is equal to tangent of x to the power 1 over x. So as I said, in this case, when you have x as exponent, your x is in the exponent, and your x is in the base, right? So we have to apply the Allen trick. So we have to apply. So x is in the exponent and in the base. Okay, so then we have to apply the Allen trick. Okay, so then step one, log trig. Okay, so first step, step one, you have to apply ln to both sides. Natural log to both sides. Okay, so so on the left side, I have h of x, and on the right side, I have tangent of x to the power 1 over x. Okay, so I'm going to apply natural log to the left side, natural log of h of x, and then natural log of this tangent to the power 1 over x. And the point is, so why do we apply a natural log? Because now I can bring this power down here. Okay, so now it's ln of h of x equals to 1 over x, okay, times natural log of tangent of x. Okay, so now I have step 2, right? In the next step, so we have to compute the derivative. So now step 2, compute the derivative of both sides. Derivative of both sides. Okay, so let me write it down again here. Natural log of h of x on the left, and on the right, it's 1 times 1 over x times natural log of tangent of x. So on the left, what will be the derivative? Well, as we said, like in the previous example, we said when you have like natural log of some function, right? Like, so when you have, so the rule is the following. So if you have natural log of, let's say, of g of x, okay, then the derivative would be g prime over g. So here I have natural log of h. So then the derivative would be h prime over g. H prime over h. Okay, so then derivative, it's h prime of x over h of x. Okay, so my g, so you see the g here in this rule, the g is h, right? Now, so that's for the left side. For the right side, well, so which rule I'm going to apply? So this is 1 over x times natural log of tangent of x. So we have a product, right? So this time 1 over x times. So this is a product, right? So if it's a product, so we have to apply the product rule. And what's the product rule? So if you have f times g, that will be f prime g plus f g prime, right? So the 1 over x, that's your f, and this natural log of tangent, that's your g. So it's f times g. So the derivative is f prime times g plus f times g prime, right? Now, so first I need f prime. So what's f prime, right? So you see here, guys, I need f prime. So f is 1 over x. So what's f prime? What's the derivative of 1 over x? Any guess?
Minus 1 over x squared.
Yes, very good. Minus 1 over x squared. Thank you, Mamadou. So it's minus 1 over x squared. Very good. So you can apply the quotient rule, or you can also apply power rules. If you move the x to the top, that will be x to the power -1, right? And so you have the choice here, either the quotient rule or just you can move the x to the top, that will be x to -1, and you apply the power rule. Now, f prime times g, right? So times g, that's the ln. The g is the ln of tangent of x, right? And then plus f is so f is the 1 over x, so it's plus 1 over x. So here, let me just because I'm gonna need some space here. So here I'm computing the derivative, of course. This is the derivative. So we said plus f is 1 over x times g prime, okay? So now the question is, what's g prime, right? G is ln of tangent of x. So what would be g prime? Any guess? What's the derivative of ln of tangent of x? Well, Adrian, secant square, that's the derivative of tan, right? That's the derivative of tangent of x. My g, you see here, g, we are saying g is natural log of tan. The g is this whole thing here. It's natural log of tan of x. So remember, guys, the rule, we said if you have natural log of some function g, if you have natural log of some function g, then the derivative is g prime over g, right? So here I have natural log of tangent, okay? I have natural log of tangent. So then the derivative would be the derivative of tangent over tangent, right? So the derivative of tangent of x, that would be secant square of x over tangent of x. So again, guys, what I'm applying here is this rule, this one here. Okay, so if you have ln of some function, then the derivative would be the derivative of that function over the function, right? So here I have ln of tangent of x, then derivative would be the derivative of tangent over tangent. Okay. Okay, so yeah, so that's the derivative of ln of tangent of x. Does it make sense to you, Adrian, why it's secant square over tangent? So yes, okay, perfect. Okay, so yes, so it's not just derivative of tan, it's derivative of a natural log of tan. Okay, perfect. So then, yeah, so then I have to solve, of course, because the goal is to compute h prime of x, right? So I have to solve now for h prime. Solve. Sorry. So we have to solve for h prime of x. So we have to multiply both sides by h of x, right? So we have to multiply here, have to multiply here by h of x, and here the whole thing by h of x, right? This whole thing here by h of x. So it's gonna be, so then h prime of x is equal to h of x times, because when you multiply by h of x, you see the h of x in the bottom, and the h of x the top, they cancel out. So it's gonna be just h prime equal to h of x times the whole thing. So times -1 over x squared times this ln of tangent of x, right? Plus this 1 over x times the secant square of x over tangent of x. Now, what's h of x? What's this? What's this h of x? Well, that's our original function, right? That's our original function, which is the tangent to the power 1 over x. So that's so then h prime. So then my h prime of x is the tangent of x, the whole tangent of x to the power 1 over x. That's my original function, times this whole thing here, minus 1 over x squared times the natural log of tangent, plus 1 over x times the secant square of x over tangent of x. Right? So, and that will be a fine answer. Okay, so here we have to solve, of course, for h prime of x. Any question, guys? Okay, no questions. Then let's do the next one, the cosine of x to the power x. So I'm gonna move to the next page again. Number 2. So I have this cosine of x.
Professor,
Yes.
can you go back a little bit?
Oh yeah, sure. Sure. Is that the answer you got, Mamadou? Is that the same thing? Okay.
Thank you.
Okay. Okay, so then, so for next one, we have cosine of x to the power x, all right? So same idea, because I have x in the exponent and x in the base, so you have to apply this log trick. So log trick, again, because x is in the exponent and in the base. If x was just in the exponent, like if you have some number to the power x, like 3 to the power x, then you can apply, that will be exponential function with base 3, right? So if x was just in the exponent, then that would be just exponential function. And if x is in the base, then you can apply the power rule or wherever, right? But x here is in the exponent, and this is the key word here. X is in the exponent and in the base too, right? So that's why we have to apply this log trick. All right, so so step 1, so we have to apply. So here's my h of x, cosine of x to the power x. So we apply a natural log both sides. So here's my natural log. Here's my natural log. Probably I'm gonna move this to the here. So this is natural log of h of x, and this is natural log of this cosine of x to the power x. Now, as usual, as I said, the point of applying the natural log is because we can bring down this power here here to the front of a natural log. So then we're gonna have natural log of h of x equal to x times natural log of cosine of x. Okay, and so and then next step, of course, would be to compute the derivative. So step number 2. Okay, so we're going to compute the derivative. So derivative. This is here's the derivative 2 on the other side. So what's the derivative of natural log of h? So that's, again, it's like natural log of some function g, right? And we said natural log of some function g, the derivative would be g prime over g, g prime over g, right? If you have natural log of some function, derivative is the derivative of the function over the function. So natural log of h, derivative is h prime over h, equal to, now the right side, it's x times, so because I have this times, x times natural log of whatever, because of the times, the multiplication, then you have to apply, of course, the product rule. And the product rule, f times g, derivative, is derivative of the first function times the second, plus the first function times the derivative of the second function. All right, so what's f? My f is the first function here, and my g is this natural log of cosine of x. That's my g. All right, so we need first f prime. F is x. So f prime derivative of x is just 1, right? Power rule. This is like x power 1. So 1 times g times the natural log of cosine of x plus, you see there's a plus here, and then f, that's x, times g prime. So now the question is, what's the derivative of natural log of cosine? Any guess? What would be the derivative of natural log of cosine?
Minus sine over cosine of x.
Yes, very good, Mamadou. So it's g prime over g. G is cosine, so it's minus sine of x over cosine of x. Very good. Which is minus tangent, right? So, so let me just right here. So this is h prime of x over h of x. It's natural log of cosine of x minus this x times sine over cosine. That's the definition of tan. So that's tan of x, tangent of x. All right, sine over cosine, that's tangent of x. Well, so Oh, sorry, Ibrahim. Yeah, sorry. Yeah, sorry. So I have to multiply. Now I want to solve for h prime. So solve. So we have to solve for h prime. So solve for h prime of x. So we're gonna multiply here by h of x and here by h of x. So then h of x cancel out. So that's so then h prime of x is equal to h of x times, so this h of x times the whole thing, of course. So then times natural log of cosine minus x times tangent of x. All right. Now the question is, there's one last thing to do here. Just replace h of x. So we know what's h of x, right? That's our initial function, right? So that's so our h prime of x is gonna be equal. So what's h of x? H of x was, this is our h of x. It's the cosine of x to the power of x, right? So that's cosine of x to the power x times natural log of cosine of x minus x tangent of x. Right, and so yeah, so that's a fine answer, of course. It's a fine answer. All right, so it's the same trick, same steps. All right. Any question, guys? All right, no question then. Okay, so then we are done with this section 2.7, log and exponential. So we know how to compute derivatives of log, of exponential, and even functions with the x in the power and in the exponent and in the base, right? So now let me come back to the section 2.6, right? So so next section. So let's come back to the section 2.6. And probably this is the last section where we have to, where we have to compute derivatives, okay? So the section 2.6 is about the implicit differentiation. So implicit differentiation. All right. Okay, so what's the idea here, guys? So what does it mean, this implicit differentiation? So let's say you have some function of x. Okay, y of x be a function of x. A function of x. Okay. Example. Let's just say y of x is equal to x squared minus x, right? Or if you prefer, so y is a function of x, so y is equal to x squared minus x. Okay. So here in this case, the function y, which is a function of x, is defined explicitly in terms of x, right? I mean, we have the exact expression of y of x in terms of x, right? So this is the y of x here, the y of x is actually defined explicitly in terms of x, right? In terms of x. So we have the exact expression of y of x, right? We know that y, or y of x, is equal to x squared minus x, right? In terms of x. Okay, so that's for example 1. Example 2. All right, so let's say you have, let's say I have x cubed plus y minus 2x equal to 3, right? And again, I'm going to suppose that y is a function of x. Okay, y is a function of x. Well, here, I mean, this is just an equation, right? So we have some relation between y and x, right? This is, this is this equation here. So this is this equation here. Well, this equation defines some relation between y and x. But then you can solve, we can solve for y. We can solve for y. Can solve for y. And then, we solve for y. So then your y would be equal to, you can add plus 2x here, plus 2x here. And then you can subtract x cubed. You can subtract x cubed here. So then y would be equal to, 3 plus 2x minus x cubed. Okay. So here we succeed to solve for y. And so y, as you can see, y is a function of x. And we have, the exact expression of y. So we have, so then your y of x, so y as a function of x is equal to 3 plus 2x minus x cubed. All right, so so we have the exact expression of the function of y of x, right? We can solve for y. The key, the important thing here is that we can solve for y. So then we have the explicit expression of y of x. Now, let's say we have another example. Example 3. Okay. And again, so y, you need to think of y as a function of x. So when I say y is supposed to be a function of x, right? And now let's say we have the following equation. So let's say we have x times y plus x squared times e to the y minus cosine of x times cosine of y equals to 2, right? So we have this relation between, this equation here describes a relation between x and y, okay? We have sort of relation between x and y, right? The question is, can we solve for y? Can we have an exact expression of y, okay? So the question is, can we solve for y? Can we solve for y? In other words, can we have the exact expression of y in terms of x? In terms of x. Right. You see, in the previous example, I had this, this x cubed plus y minus 2x equal to 3, right? And then it's easy actually to solve for y, right? So then y my function y of x, my y of x is equal to 3 plus 2x minus x cubed, right? So I solve for y, and I got the exact expression of y of x, right? So then your y of x here is defined explicitly in terms of x. In terms of x, right? Because we can solve, we can solve for y. Now, what about this example number 3? Do you think, guys, we can solve for y? Is there a way to solve for y?
No.
No. Yeah, absolutely, Ibrahima. So yeah, we cannot really solve for y. I mean, we have x times y, and then we have exponential of y, and then we have also cosine of y. So in this case, we cannot solve for y. So the answer, so you're right, Ibrahima. So we cannot solve for y. Okay. So you see, sometimes you can solve for y. You can get the exact expression of y in terms of x, but sometimes it's just not possible, to solve for y. So you cannot really have the exact expression of y. Okay. So in this case, so when you have a relation or an equation between, a relation between x and y, and you cannot really solve for y. So we say that actually the function y is implicitly defined. Okay, so in this case, we say that y is implicitly defined. Implicitly defined by the equation. So it's not explicitly defined because you cannot solve for y, right? You cannot have the exact expression of y. So it's not, y is not explicitly defined, right? Because you cannot solve for y, right? But still, you have this equation, which is sort of, describe a sort of relation between x and y, right? And so we say that y is implicitly defined by the equation, right? Now the question is, so we are, of course, we are interested in the derivative, right? So when you solve for y, so for example, here in this example number 2, with this equation here, we can solve for y. It's equal to 3 plus 2x minus x cubed, right? And so you can compute the derivative, right? Y prime of x would be like, a derivative of 3 would be 0. Derivative of 2x would be 2 minus derivative of x cubed, that would be 3x squared, right? Anyway, so my point is, because you have the exact expression of y, you can easily compute the derivative of y, right? Now the question, if y is implicitly defined by an equation, can we still compute the derivative? Okay, so the question now is, so if y is implicitly defined by the equation, can we still compute the derivative of y? So can we compute y prime of x, the derivative of y, if y of x is implicitly defined? Okay. So again, guys, when I say implicitly defined, it means that we cannot really solve for y. So we don't have the exact expression, the explicit expression of y in terms of x. Okay. So you have sort of like when I say implicitly defined, you can think of this, this equation here where you cannot really solve for y. Okay. But still, y is a function of x, right? So if y is a function of x, it means that we are supposed to compute the derivative of y with respect to x, right? Because it's a function of x. Y is a function of x. So you are supposed, in theory, you're supposed to be able to compute the derivative of y, right? However, there's a problem, and the problem is you cannot solve for y, right? You cannot have the exact expression of y. So the question is there another way to compute the derivative, even if y is implicitly defined? Okay. Does this make sense to you guys? Does the question make sense to you? Okay. So yeah, so we wanna compute the so the question is, can we compute this derivative if y is implicitly defined? And the answer, yes. The answer, yes, we can compute y prime of x via the implicit differentiation. So the answer, yes, we can compute y prime of x using the implicit differentiation. Okay, so now let me give you an examples, right? So let me show you how this implicit differentiation works, all right? So examples. Again, so y supposed to be a function of x. So y is y of x, right? So y is supposed to be some function of x. And then, so I'm supposed to be able to compute y prime of x, the derivative of y of x. First example, example one is, let's say, x squared plus y squared, right, equals to 1. Okay. So I wanna compute. I wanna find y prime of x using this equation, right? So I wanna find y prime of x. Okay. Oops. So yeah. So let's just compute the derivative of this equation, right? So I have I have x squared plus y squared equals to 1. So let's compute the derivative of both sides. Okay, so what will be the derivative? All right, so let's start with the x squared. So this is x squared plus, this is x squared plus y squared. So if you want to compute the derivative, I mean, you don't need a product rule or quotient rule or anything because it's a plus here, so it's a sum. You have addition here, and if you have addition, then you don't need any rule, right? So first, I need the derivative of x squared. So what's the derivative of x squared? Well, it's just 2x, right? Bring down the power in front of x. That will be 2 times x to the power, 2 minus 1. That will be 1, right? So that's 2 times x. So here, supposed to subtract 1. So here it's just x to the power 1, right? And then plus Okay. Now the question is, what's the derivative of y squared? Any guess?
2y.
2y. That's not true. That's not true because, you know, if it was x squared, then yes, Ibrahima, that would be Adrian. That would be 2x. But this is y squared, and y is this function of x, right? So, so let me just remind you, you know, when you have some function to the power n, remember at some point we said that we can use, so if you have, let's say, h of x equal to f of x to the power n. So we said we can, because the thing is, y here, this y is supposed to be a function of x. It's not it's a function of x, right? Y is a function of x. So it's like you have a function of x to the power 2, right? Or function of x, a function of x, f of x to the power n. So what's h prime of x then? If, let's say here you have, you know, you have this, so this power n or power 2. So what's h prime? Well, this thing here, f to the f of x to the power n, this is the chain rule, right? This is some function to the power n. So it's a composition of two functions, right? The power and the function f, right? So this is composition of two functions, right? This is composition of two functions.
It's a n multiplied by f prime of x over f the x.
Yes, very good, Ibrahima. Exactly. That's the, yes, we said the rule. So that, and it's a consequence actually of the chain rule. That will be n f prime of x times f to the power n minus 1. Okay, so if you have a y squared, then if you have y squared, so if you have y squared, then the derivative would be y squared. The derivative, so your n is equal to 2, right? So then it would be 2 f prime, so 2 y prime, and then y to the power n minus 1, so to the power 2 minus 1, right? So there'll be 2 y prime y to the power 1, which is y. So derivative of y squared is actually 2 y prime y, okay, equals to, right? So does it make sense to you guys? Again, this is a consequence of the chain rule. I think we saw this in the section 2.3 or something, 2.4 probably, right? So if you have a function to the power n, and as a consequence of the chain rule, this is a composition of two functions, right? F and the power n, then derivative is n f prime f to the power n minus 1, right? So yes, so derivative of y squared, it's not just 2y, it's 2y y prime. The y prime is really important. And that's because, so then, and then, so you can solve for y prime. Remember, our goal is to find y prime of x. You want to find y prime. So that's why, because you have this y prime, you can solve for y prime, and then you can get your derivative. And now, what about the other side? Of course, so we compute the derivative of the left side. What about the right side? What's the derivative of 1? I mean, 1 is just constant by itself, and derivative of a constant by itself is 0, right? So this is 0, right? So anyway, so what we are saying is that when you compute the derivative of the equation, so we have 2x plus 2y prime y equal to 0. And the goal is, again, the goal is to find, y prime. So we have to solve for y prime now. So we solve now. This is so once you compute the derivative, you solve. So the second step, step 2, let's say. First step, you compute the derivative. Okay, then step 2 would be to solve for y prime. So now I can solve for y prime. So we have 2x plus 2y prime, y equal to 0. We can subtract 2x, both sides. So then 2y prime, y is equal minus 2x. We can divide by 2. Actually, we can divide by 2y. So here I'm going to divide by 2y and here by 2y. So then, of course, 2 over 2 cancel out, and y here over y cancel out. So it's just now y prime, my derivative, y prime of x is equal to minus x over y. Okay. So y prime of x is minus x over the function y. And of course here, I cannot really replace, I don't know the exact expression of y, right? So then I cannot really replace the y by its exact expression, right? Because I don't know what's the exact expression of y. So then, this is your derivative y prime of x, okay? Any question, guys? I see there's a question in the chat. Oh, yes, absolutely, Adrian, yes. Yeah, absolutely. That's so you're talking about this f of x to the power n, right? Yes, I mean the y square, yes, okay, so yeah, that's a good point. So again, the rule, our rule is actually a consequence of the chain rule. So yeah, so again, so let me just remind you. So let's say your function, it's y squared, right? Let's say this is h of x is equal to y squared. And again, y is supposed to be a function of x. So yes, you can write this. This is a square of y, right? This is square of y of x. So that's the form f of g, f of g of x. So your y of x would be g of x, and f would be the square, right? So you can say, you can say f of x is equal to x squared, and g of x is equal to y of x. Okay, so then your h, it's just f of g, right? It's y squared, right? And so your h prime, as you said, h prime, it's g prime, f prime of g. So what's g prime? Well, g is y, so g prime is just y prime. Okay, so this is y prime of x. That's my g prime. Now, what's f prime? Well, f of x is x squared, so f prime of x is 2x. Now, what would be f prime of g? What's f prime of g? Well, that's, you substitute x by g, right? This x here, you substitute by g. So g is y, so that would be 2y. Okay, so f prime of g would be 2y. So this f prime of g is 2y, or 2y of x. So yes, you see h prime is actually 2 times y prime, or 2 times y prime times y, right? That's exactly our the answer we had, right? So h prime derivative of y squared, it's 2 y prime y, and that's exactly our answer, right? We said it's it's the you know, here we said, so if you apply this rule, you know, this one here, f of x to the power n, we said the derivative would be n f prime f to the power n minus 1, of course, right? And so we got the same answer. We got this 2y prime y. And this is, again, this rule is just a consequence of the chain rule, okay? It's not really it's a consequence of the chain rule, right? Yes, so that, I guess that answers your question, right? Thank you. Yeah. Yes, guys. So this is how we compute the derivative of y using the implicit differentiation. So all you have to do, so I'm going to do one more example, but all you have to do is to compute the derivative of both sides of the equation and then solve for y prime. Okay, so let's do another example, and then I'm going to give you an exercise. Okay. So one more example. Example number 2. Okay. So let's say I have y to the power 5 plus x times cosine of y, all right, plus y times e to the x equals to 1. And of course, again, you think of y as a function of x. Y is supposed to be a function of x, right? And the thing is, again, we don't know the exact expression of y. All we know is this, you know, this relation between y and x, or this equation which describes a relation between x and y. But the problem, as I said, the problem is we cannot, so like in this case here, we cannot solve really for y, okay? So we cannot have the explicit expression of y, okay? So here again, we cannot solve for y. I cannot, because of the, we cannot solve for y because there's a cosine of y, right? And there's this y to the power 5, etc., etc. So even if you try, I mean, you cannot actually, you cannot solve for y anyway. Okay. And but however, I wanna, oops, sorry, I wanna, you know, I wanna compute the derivative. Okay. So I wanna, so the question is to find the derivative of y. So I wanna find y prime of x. Find y prime of x. All right. So there are 2 steps. Step one, we have to compute the derivative of the equation, derivative of the whole equation. Okay, so we have this. So let me write down again the equation. It's y to the 5th plus x times cosine of y plus y times e to the x equal to 1. Okay, so let's start with the left side. First, I mean, we have a plus here. There is a plus here. Okay, so then all you have to do is to compute derivative of this thing here, y to the 5th, then derivative of x to the power x times the cosine of y, and then plus the derivative of this y times e to the x. So let's start with the y to 5th, right? So what will be the derivative of y to the power 5? Any guess? Derivative of y to the power 5, y 5th. Again, y is a function of x. So it's like function f to the power 5.
5 times y prime times y to the power 4.
Yes, Ibrahima, thank you. Absolutely. So, absolutely. So it's y 5y prime y to the power 4. Okay, and so which rule we applied? Well, it's you know well, the same rule we applied before. So if you have this one here, if you have some power, so a power n of the function f to the power n, then we said f to the power n, then we said derivative, it's n f prime times f to the power n minus 1, right? So if you have y to the power 5, the derivative would be 5 here, y prime here, and here y to the power 5 minus 1, so that's y to the power 4. Okay, so yes, Ibrahima, that's 5y prime y fourth. Then we have a plus. Okay, now what about the next one? X times cosine of y. So x times cosine of y, it's a product, right? So we have to apply the product rule. Right? So any guess what would be the derivative of x times cosine of y? So product rule, it means that like this would be my f and this would be my g, right? And the product rule would be, f prime g plus f g prime, right? So any guess what would be the derivative?
1 times minus sign.
Well, you don't have to change. So 1, that's the f prime, right? So
yes.
Times g. So it's the same function, right?
Sorry.
Mm-hmm. Yes, Ibrahim. So it's 1 times cosine of y
And
plus. Go ahead.
Sine of minus sign.
Minus sine. So minus here. Okay. Minus x times sine, or just minus sine? You're saying.
X.
Okay, minus x sine.
Sine.
Sine of what?
Sine of y over cosine of y.
Sine of y over cosine of y?
Yeah, because you say the cosine of y is a function, right?
Yeah, I said y is a function. So we have cosine of y.
Yeah, that's what I'm saying. It's times sine of y over cosine of y.
Like this?
Yeah.
Well, that's not true. I mean, this is not like a natural log of cosine of x. Okay, so we want to, yes.
Times x times, x times the sine of y.
Not enough.
Not enough.
Yeah, there's one missing term. So, okay, so the idea is, you have cosine of y, right? So f of g, right? So it's composition of two functions. F is the cosine, and g is the y, right? So we have to apply the chain rule, which is g prime f prime of g, right? So g prime, what will be g prime? That will be y prime. And f prime, as you said, f is cosine. So f prime is minus sine of what? F prime of what? F prime of G. So it's minus sine of Y.
Oh,
Okay, so there's this Y prime missing. So here, there's this Y prime missing. Okay, so it's minus X times Y prime sine of Y. You see why? Does it
yeah,
now make sense? You see, cosine of Y, it's composition of two functions. It's not, I think you applied the rule for natural log.
yeah.
Yeah, so this is, I mean, here we don't have a natural, we don't have a log. It's cosine of Y, so it's composition of two functions, F and G, where F is cosine and G is Y, right? Oops. Oh, it's time. All right, guys. I think. I mean, I don't have time to finish. I guess this exercise, this example. So I guess I'm gonna continue this. So I'm gonna stop here. So I'll continue this next time, next Monday, I guess. So yeah, again, guys. So tomorrow I will post the homework number 8. Actually, I didn't finish grading the homework number 7. So, but anyway, so tomorrow I will post the homework number 8 with the extra credit. All right, and I will see you next Monday. All right.
Okay, bye, Professor.
Thank you, everyone. Good night. See you next time. Take care, everyone.
Thank you. Good night.
Thank you, Ibrahima. I'm sorry for.
No, it's fine.
Yes, thank you.